Good afternoon. Now I am going to take about the capacitance of a material. In the past video, we have seen the resistivity and conductivity of the material. These are the basic properties of a material. Now, the capacitance of a material. What do you mean by a capacitance? It is the property of a material to be store the electric charge in an electrostatic field. See, in a simple way, if we say the capacitor, two conducting plates placed at a distance will get a dielectric nature. That is, dielectric means the charge will be aligning on the two plates at a particular distance. If we keep two conducting plates and the charges will be aligned on the plates. So the capacitance is simply called as it is the ability of a material to store the charge in a electrostatic field, in the form of electrostatic field. So we can say that we will assume a parallel plate capacitor, that is two conducting plates placed at a distance of 2D. We will say placed at a distance of 2D. See, when the capacitor is connected in a DC supply and if it is connected in AC supply, the behavior of the capacitor varies. First of all, the capacitor is the thing in which the current will never flow inside the plates. The current will be on the surface of the plates. That is, there will be no conduction inside. There will be no conduction in between the plates. That is, every conduction will be happening on the surface of the plates. Now simply I am comparing the nature of the capacitor when you supply a DC to DC and when you supply a AC supply. What happens to the capacitor and how it does function? We can see that now. The capacitor, as I said, the two conducting plates placed at a distance is connected to a DC supply. So this, in DC supply, the electric charges on the plate will get accumulate. That is, here I am connecting a positive supply. So here the positive charges will get accumulate. Once the supply is connected, this will be moving. The positive charge will be discharged from the battery and stored on the surface of the plate. Or else we can say in another way, the negative conducting plate is that it stores charges, I said. So the conducting plate may have electrons, positively charged particles and negatively charged particles. So this negative charged particle in the plate will flow towards the battery supply. So we can say like this also, the positive charge from the battery moves towards the plate, or else negative charge flows towards the battery. You can say similarly in this way, the negative charge will move and the negative charge will get accumulate on the negative terminal of the battery. Okay, what happens? See, the battery, the full charge is completely accumulated on the surface. Simply we can say the capacitor is fully charged. What happens if the capacitor is fully charged? That is, once the capacitor is fully charged, if you connect a DC supply, then this will never allow DC. So for a positive half cycle, so the DC will be of only positive. So for positive half cycle, once it is fully charged, there will be no means of discharging. That is, capacitor blocks DC. In this way only they are saying that once it is fully charged, it will never allow the flow of electrons or positive charges to flow in the circuit. So that is, the circuit reaches no flow of charges, no flow of current. So we say the capacitor blocks DC current. This is the reason why the capacitor blocks DC current. Similarly, if I am supplying a AC supply, that is phase and neutral, positive, there will be a positive half cycle and negative half cycle will be there. I am supplying the same thing. The electrons will move towards the supply and positive charges will move towards and the charges will be accumulated on the plate. Once this is done for a positive half cycle, that is positive, let us assume that this phase neutral is positive and negative terminal of a battery. See, once during the positive half cycle, the current will flow, like the supply will be like this. During the negative half cycle, during this period, the supply will be minus plus. So what happens is that here the negative, as I said, negative will flow towards here. But once the supply, during negative half cycle, once the supply is reversed, this will be flowing in this side. So that is, the positive charges will move towards the negative terminal. The same way in a reversed thing. Then the negative charges will move towards the positive terminal. So in this is the thing while say during positive half cycle it is charging, and during negative half cycle like charging and discharging happens in a phase shift way. So once we can say that capacitor blocks DC current, and but for AC supply the capacitor allows AC current to flow through. Capacitor allows AC current and blocks DC. This is the reason why. That is, during positive in the DC supply only positive half cycle will be present. There will be no means of reversal of supply. But during when we are supplying AC supply, the current will be the terminals will be interchanged during positive and negative half cycle. So it is of the, because this is the nature of the alternating current in which the capacitor allows AC current to flow through. Then next, now we are entering into the topic that we need to study of electrical properties of a material, the basic things we have learned. The next is this, the materials which specified materials they have given in your syllabus is that nanomaterial, and another one is a fiber material. Why nano? Why I have to study about the nano? Nano is a very advanced research techniques. So still it is in a research field, but the nanomaterial is one which has a thickness very much less than 10 power minus 9. The thickness of the nanomaterial is very less than 10 power that is less than that of 100 times the 10 power minus 9. Nodi, 100 times the into 10 power minus 9 meter. So nano is we will simply will say what does mean by nano is that nano is 10 power minus 9. The material which is made with that much less amount of thickness, then it is called as a nanomaterial. Most of all, nanomaterial is made from carbon atoms or graphites. As a textile and FT, fashion technology, why we have to learn the nanomaterial is that for a different property, for attaining a different property, we need to know about the nanomaterials. If you coat a nano coating on the fiber materials, what are the nature does it behave? Why we have to study the electrical property of nanomaterial or nano coated material is that the electrical property of a normal atom varies when it is of nano size. If you are manufacturing a nano atom, so the electrical property of the normal material varies with the nanomaterial. So you have to convert. So you have to analyze the properties of the nanomaterial also. Based on the structure of the nanomaterials, it is formed. That is, there are different types of structures based on which the carbon nanotubes or nanomaterials are coated. Based on that structure, the material will act as a conductor or a semiconductor or insulator or superconductors. Based on the nature of conductivity is desired by means of nanostructures it is formed. There are different types of nanostructures and different types of electrical properties available for the nanomaterials. We will see only the conductivity of the nanomaterials because nanomaterial is a very wide topic. So I am just stopping alone the conducticity of the materials. The conductivity of nanomaterial depends on nanostructures, as I said. So one is, the first structure is armchair structure. The carbon atom which has been formed is in the form of armchair. This will be like this, armchair. As we know that the carbon atom is of this six structured carbon atom, so the layer will be of like this. It will be, that is If we take the outline of the layer, it will be like a chair, armchair structure. So for armchair, if the nanomaterial or carbon material made of armchair structure is of armchair structure, then it behaves like a metal. It behaves like a metal. So as all we know that the metal is a pure conductor. Metal conducts, all type of metal is a pure type of conductors. So armchair is a conductor, pure conductor. Armchair structure type of nanomaterial is a pure conductor. Similarly in zigzag, so it is, the structure will be of zigzag type. The carbon structure rolled to form in a zigzag way. If the structure is of like this zigzag way, then it is, because it is rolled in this like this, the way of electron flow in this structure varies with this structure. Here it will be, there will be a continuous flow of electrons in every atoms. So it is a pure, it acts as a metal, so it is a pure conductor. But in zigzag, there will be a disturbances because the energy band gap varies while comparing with the armchair structure. So, this zigzag conductor, the zigzag type of nanostructure behaves like a semiconductor. The next is a chiral. Chiral is like a chain link. The structure will be of totally chain linked. The carbon atom structure will be of chain linked. So this is also will be, there will be a distraction in the flow of electron continuously. So it may sometimes partially conduct, or sometimes it never conducts. Based on the application, we may use it as a partially conducting or a fully conducting material. So chiral structure is also a semiconductor. Thus we conclude that armchair structure is a conductor, pure conductor. Zigzag structure is a semiconductor material. And chiral and zigzag is both is a semiconducting material. So based on the structure it is formed, the conductivity varies. This is the thing we have to consider while selecting the nanomaterials or coating the nanomaterials. Simply, if I am saying that a jute material is coated with a carbon atom, okay, graphite layer is coated with a jute cotton fabric material. So once it is coated, its electrical properties varies, its insulating properties varies. So this depends on the first thing, the conductivity of the material depends on the folded structure. Then it depends on the number of valves, number of layers or number of valves on which how much amount of layer of coating is done, number of valves. And another one is area density, that is we will simply consider for area, a cross-sectional area of the material. So these three things, based on these three things, the conductivity of the material changes, whether it increases or decreases. That's all. This is the thing, the electrical property of a nanomaterial. Next, the next topic is electrical property of a fiber material. First of all, what do you mean by a fiber material? Fibers. So as in a simple term, fibers means there are different types of fibers. Based on the application towards the fashion or textile, we will be classifying it as a cellulose, jute, cotton. So cotton will come under cellulose fibers. So these things may be also included with the electro-textile fibers. So for a material to be known, its electrical properties for electro-textile fibers. Nowadays, while we are wearing a fabrics or textile materials, there are different application of conducting materials. They are keeping in even in dresses or threads. Everything they are keeping an electrical type of materials. And if it is a fitness side, they are keeping a tracking devices, it is of conducting, then it is a space operants in a military applications. So everywhere there will be a conducting materials they are placing in the fabrics. So we need to know the how the electrical property of a fiber is depending on this. And also for providing insulations, we need to providing safety insulators, insulating gloves, dresses, we need to know about the whether it is conducting or not. So we have to study the electrical property of the textile fibers. So there are different properties of textile fibers available. The major thing in which the insulation properties of a fiber is depending is that dielectric property, static electricity and electrical conductivity. Dielectric property. The dielectric property is simply we say dielectric. It is the property of a material to get polarized, or else it is the property of an insulating material. Property of a insulating material to get polarized. When electric field is applied. So dielectricity, see, if it is in terms of dielectricity, we can then move towards the capacitance. The capacitance and dielectricity is interrelated thing. The next is static electricity. This thing everyone knows, that static electricity. While rubbing a material, if I rub a paper with my hands, the paper will be sticking to this because of the static or because of the charges generated on the surface of the paper and to charge transaction that happens between the paper and towards my hand. So the paper will stick to my hand. So like these things, by rubbing the material, we provide we create a charge transfer between the materials. So that is called static electricity. So the static electric generation in the fiber materials may cause severe damage while manufacturing itself, because while in a spinning industry or spinning mills, once it has a secretion of or generation of static electric charge while rolling towards the in a spinning mills, the steel rolls will be there. If it is of conducting or static electric charge, so that may lead to different problems. So there may be a short circuit may occur in machines because the yarn will be going inside the materials. So we need to know the static electricity. And also if I am wearing a polyester thin material, that is the fiber which is made of polyester, so and I am rubbing with cotton or cellulose fibers. So because of that we have to study the fiber materials. If I rub those two fiber materials, there may be a chance of static charge. So we need to know the electrostatic series of the fiber materials. So by rubbing this material with that material, it should not generate static electricity. So even though if it is generated, that should be nullified. Or else for insulation purpose, if I use this material with this material, there will be no static electric generation will not be present. I have to assure that and give to the manufacturing unit. So we have to know about the static electricity. Next is the electrical conductivity. Electrical conductivity is if there is a minimum electrical conductivity in the electrical insulating safety materials, what happens? If there is a minimum, even though if it is of my 0.5 percentage of conduction of electricity is there, the person will feel shock. So we should remove the conductivity, or else we should improve the resistance of the material. So we have to study the electrical conductivity of the fiber materials. So the first thing is dielectric property. As I said, dielectric property is the property of a material. So we can say, we can say that two parallel conductors placed at a distance. So this medium, this medium here I have considered as air. So that is called a dielectric medium. So the charges must overcome. The electric charges must overcome to achieve to cause the flow of electrons in it. So this potential barrier can be overcome by applying an external electric field. So this type of property, that is dielectric property, will be present for insulators. So to overcome the insulating property, we are applying an electric field or polarizing the electric field. So the dielectric property of a material depends on moisture, temperature and impurities we are adding to the material. moisture. The moisture content in the material will be present if if I'm saying that if a jute material, I'm taking a jute bag or jute material, if there is a moisture content present in the material, what happens? So simply we can say cotton dress I'm wearing, I have a moisture content, I feel wet. So if it is means of conducting, then what happens? Yes, if there is a moisture content regains in a material or a fabric, what happens is that moisture is nothing but we can say water will be present. So H plus O minus, O2 minus. So these positive charges will align in one side and negative charges will align, creating a dielectric dipole at a distance of 2D. Then this is called a dielectric is created. So this will get polarized because of the atmospheric conditions, or when a conducting medium is brought towards it. So we need to see the polarization effect based on the moisture content. So this dielectric property will depend on moisture content. So that is based on if the moisture content is present in the material, electrical conductivity will increase due to polarization. That is, dielectric strength will decrease. Dielectric constant will increase. This shows that dielectric strength is nothing but breakdown voltage, that is the voltage to overcome the insulating property to conductivity property, that is breakdown voltage. Simply we can say breakdown voltage. If there is any impurities present in the material, what happens? If there is an impurity present, this will cause the flow of current. If the impurity is of conducting material, then that will allow the electrons to flow through it, then the material may conduct. This is also a severe problem we have to notice. Then effect of temperature. The effect of temperature is that the resistance of the material varies with temperature, we know. But what is the dielectric property and temperature? If the temperature increases, there will be a change in moisture content. There will be a change in the thickness of the material, or the elasticity, elongation of the material. So there will be a pores, impurities may present inside. That will also causes the changes in the electrical property of the material. The next is electric, as I said, static electricity. While rubbing the material, that will generate a electric current. So that should be avoided. So we need to see the static electrostatic series, which is made particularly for fiber. That I will show in the next session. The next is the electrical conductivity. The electrical conductivity, similarly, the material may act as a conductor, insulator and semiconductor. The textile fibers or fiber materials which is used for making fabrics, these materials, or simply we will say everything is of insulators. Blindly we will say it is an insulator, but it is not at all an insulator. That may be an insulator or a conductor or a semiconductor also. That is, for semiconducting devices, we can choose the different types of materials. Jute, if it is of nano coated, the electrical property. See, in some other industries, nowadays there is a different types of textile materials or there whatever we are seeing, that there is a color changing fabric. For a particular amount of time, that color will be displayed, that fabric will be of in blue color. Then after particular hours, it will be of green or rose or any other colors. So this is because of based on the temperature change and the effect of the material they are manufacturing. So this is also will come under the electrotextile fibers. So we need to know the conductivity of the material. The conductivity of the material also depends on the moisture content, temperature and impurity. Moisture content, what will happen? See, if water is present, water is a pure conductor, that will allow current to flow through it. So we need to So the moisture content should not be regained. So we have to analyze what is the methods to reduce the moisture content present in the, or regain of moisture content in the fabric materials. Then impurities. Impurities such as additionally, as I said, the same thing, the conducting material is added to the impurity to the fabric, that will also causes. Temperature change. The effect of temperature is with resistivity and conductivity. If the temperature increases, resistance will decrease. That is, the conductance will increase in the material. So these are all the things which have to be noted down while seeing the electrical properties of nanomaterials and fibers. Thank you.